All right, this one says which polynomial is equivalent to the expression if n is not equal to -1. Basically, the reason it says if n is not equal to -1, then down here that would equal 0 and nothing's divisible by 0. So it's just one of those things that says this will work. So if you look up here, that means we're going to have to simplify this. When we simplify this, I'm going to want to factor. And the reason this question's kind of twisted is that it's not in the quadratic form. So we need to rewrite this. The numerator needs to be rewritten as -2n squared plus n plus 3, all divided by 1 plus n. Then when I factor this, this isn't a GCF question, and the leading coefficient isn't 1, so now I have to factor by grouping. I'm going to multiply those two together, and I'm going to get -6. Now I'm going to rewrite this, and I'm just working on the numerator here. I'm going to rewrite this as -2n squared, and then I need to figure out what two numbers multiply together to give me -6, but add up to a +1, and that's 3 and 2, 3 and -2. So I'm going to rewrite the middle term as plus 3n minus 2n, which will give me that 1n, plus 3. Now I'm going to group them together, and the GCF of the first pair is going to be a -n. Always take out that negative sign if it's part of the leading coefficient. And when I do that, I get -n times the quantity of 2n minus 3. And over here, the GCF is a -1, so minus 1 times the quantity 2n minus 3. Once I see that these two match, I know I did it right. So now my factors are a -n minus 1 and a 2n minus 3. Those are my factors. And I have 1 plus n over here, or n plus 1 over here. So in order to continue, I don't want this negative out here, so I'm going to factor out the negative as well. So I'm going to rewrite this entire numerator as -1 times the quantity n plus 1 times 2n minus 3, all divided by 1 plus n, or n plus 1 itself. These n plus 1s are going to cancel, and I'm left with -1 times the quantity of 2n minus 3. So I have -1 times 2n minus 3. I'm going to distribute that, and I get a -2n plus 3, and I keep looking for it. It looks like 2n minus 3 was there, but I don't think that one's going to be right. I'm just going to leave that one hanging. And it looks like they rewrote my solution over here. These two are definitely out. 3 minus 2n. So they just used a commutative property to switch those around. Here's how we're going to check. I'm going to store a number for n, and I'm going to type in the original, and then I'm going to type in my solution, and I'm going to verify that those two things are equivalent. When I got to this point here, it really made me want to choose this 2n minus 3. But I knew that that was wrong because I factored out that -1 means I need to redistribute the -1 to everything. So here's what I'm going to do. I'm going to store a variable or a number for n. I'm going to type 2 store n. Now I could use x if I wanted to, but I like to use the actual letter that I needed to use. And I'm just going to retype everything. This whole numerator has to be in parentheses. So parentheses 3 plus alpha, so 3 plus n minus 2 n raised to the second power. I'm going to close the parentheses, hit divided by, open them up again for my denominator, 1 plus n, close my parentheses again, hit enter. And that's going to give me -1. So now when I type these in, I'm going to be confident that my answer is right. I'm going to type in 2n minus 3 first, just to hopefully prove that I did it correctly and that this is wrong. 2n minus 3 is +1. Now I'm going to type 3 minus 2n, hit enter, and I get -1, and those two match up, so I know that these two are going to be equivalent because I verified my answer with a check step on the calculator.